This problem is y is equal to 6x minus 11. The second equation is to... sure, that's fine. Okay, so this method is called substitution. The reason it's called substitution is because you're going to substitute. So what we can see here is that we have a value. We have two different equations, and it's essentially the same question we're asking like yesterday. Where do these two lines cross? And the answer is, again, that answer is the point in which they cross, and that would be your answer. In this equation, sometimes it's really hard to graph because you're given something like this. We will talk about how to unravel this and eventually graph this, but that will be another day. What we can see here is that y is already given a value, right? Y is equal to 6x minus 11. So what we can do is we could use our second equation, and we're going to go ahead and substitute the value for y. Question? The second.
What was it? First?
The first.
It's already December? Is that 12? That's 12 right there.
So you can see here on our second equation, we're going to replace the y with 6x minus 11. Okay. So what I just did there is I looked for the y and I replaced it with, using the first equation, 6x minus 11. Okay. The reason I can do this is that they will have the same value, and it gets rid of one of the variables. So I used, in my first equation, I have y is equal to 6x minus 11. And then in my second equation, I replaced my y value with 6x minus 11. So the next thing is you just want to go ahead and simplify. So you want to first multiply your negative 3 times 6x and your negative 3 times negative 11. I'm just going to go ahead and rewrite it just to show you what I'm doing here. So negative 3 times 6x, negative 3 times negative 11 is equal to negative 7. You can omit this step, meaning you don't need to include it in case you can already do this. So now I'm going to go ahead and rewrite this as negative 2x. Negative 3 times 6x is equal to negative 18x. Negative 3 times negative 11 is equal to positive 33 is equal to negative 7. And so this starts to look like the problems we used to do, right? This starts to look like the problems we did the last, 2 chapters ago, actually. So the next thing we want to do is we want to combine like terms. So you can see here, negative 2x minus 18x. These are the same like terms. We can combine these to negative 20x. And again, you can skip some steps here in case this makes sense. Just as a reminder that when you are given something like this, you want to go ahead and move all of the constants to the other side on the opposite of your variable. So I want to go ahead and subtract 33 from both sides. We get negative 20x is equal to negative 40. And then lastly, since this is negative 20 times x is equal to negative 40, we can go ahead and divide by negative 20 on both sides. And we get x is equal to 2. So we're actually almost done. We're almost done. So since we found our x value, we can just plug it into our first equation again, since it was simplified for us. We know that x is equal to 2, so y equals 6 times 2 minus 11. We get y is equal to 12 minus 11. And actually, you can plug in the x value into either equation. That totally works. Y is equal to 1, and so our answers are x is equal to 2, y is equal to 1, or on the graph, if you were to plot this, you would see that they would cross at the point 2, comma 1. Okay. So just like before, our solution indicates where the two lines cross. So just like before, we're talking about where the two lines cross.
That's
Okay?
so hard. That's easy. No, I actually get it, like, a lot, but it takes really, really long.